Have you ever looked up at the night sky, a vast canvas of darkness sprinkled with a million tiny points of light, and wondered, how did it all begin? What is the origin of this magnificent spectacle? Where did all these stars come from, and our sun and our planet and us? These questions have fascinated humanity for millennia. It's a question that has echoed through the ages, pondered by philosophers and scientists alike, from ancient civilizations to modern thinkers. Today, we have a compelling answer, a story that stretches back billions of years to a single moment of creation, the Big Bang, a monumental event that set everything into motion. Imagine a time, before stars illuminated the void, before galaxies spun their majestic spirals, a time when the universe was a singularity, an infinitely small point. This is the realm of the Big Bang, a realm where our understanding of physics is stretched to its limits, challenging our very perception of reality. But even in this realm of the unimaginable, we can piece together clues, like cosmic detectives, to unveil the secrets of our universe's birth. Each discovery brings us closer to understanding our origins. The Big Bang Theory is not just a theory, it's a testament to the power of human curiosity and our quest to understand the cosmos. It represents our relentless pursuit of knowledge. It's a journey back to the very beginning, a grand scientific narrative that seeks to answer the most fundamental question of all: how did we get here? This quest continues to inspire and drive us forward. The term Big Bang can be a bit misleading. It wasn't an explosion in the traditional sense, like a firework detonating across the sky. Instead, picture, if you will, the entire universe, everything we see and know, compressed into a point smaller than an atom. This point was incredibly dense and hot, beyond anything we can easily imagine. This unimaginably dense point, called a singularity, contained all the matter and energy that would eventually become everything we see around us. Then, something extraordinary happened. This singularity didn't just sit there, it began to change. Roughly 13.8 billion years ago, this singularity began to expand. This wasn't a slow process, it was rapid and intense. But it wasn't just an expansion of matter into pre-existing space, it was an expansion of space itself. Space itself was growing, stretching, and evolving. Imagine the surface of a balloon inflating. As you pump air in, the surface stretches, dots marked on it get farther apart. As you pump air in, the surface stretches, and the dots marked on it get farther apart. This is a simple way to visualize how space itself was expanding. The Big Bang was similar, but instead of dots, it was space itself stretching, carrying everything within it outward. Galaxies, stars, and planets were all part of this grand expansion. This expansion wasn't a leisurely process. It was an explosive event, an unimaginable burst of energy that set the universe on a course of evolution that continues to this day. The energy released was immense, shaping the very fabric of our cosmos. It marked the beginning of time, the birth of space, and the creation of all the fundamental forces that govern our cosmos. From that moment, the universe began its journey, evolving into the vast, complex expanse we observe now. The Big Bang wasn't just a single event, it was the start of a magnificent unfolding, a cosmic drama with distinct acts that shaped the universe we see today. This colossal explosion set the stage for everything that followed, from the formation of galaxies to the birth of stars and planets. In the first fleeting fractions of a second, the universe was an inferno of unimaginable heat and energy. Temperatures soared to billions of degrees, creating a seething cauldron of particles and radiation. It expanded at an astonishing rate, a period known as inflation, cooling as it did. This rapid expansion stretched the fabric of space-time itself, smoothing out any irregularities. As the universe cooled, energy began to condense into matter, following Einstein's famous equation, E equals mc squared. This transformation was crucial, setting the foundation for the material universe. This wasn't just any matter, it was the building blocks of everything we know: quarks, electrons, and other fundamental particles. These tiny components would later combine to form the atoms that make up all matter. Over eons, these particles combined, forming protons and neutrons, the hearts of atoms. These atomic nuclei were the seeds from which all elements would eventually grow. Around 380,000 years after the Big Bang, the universe had cooled enough for atoms to form. Hydrogen and helium atoms began to emerge, filling the cosmos with the first elements. This era, called recombination, marked a pivotal moment. It was a time when the universe transitioned from an opaque fog to a transparent expanse. Light, which had been trapped in the dense soup of particles, was finally free to travel. This release of photons allowed the universe to become visible for the first time. This first flash of light, stretched and cooled over billions of years, is still detectable today as the cosmic microwave background radiation, a faint echo of the Big Bang. It serves as a window into the universe's earliest moments, offering clues about its origins and evolution. The Big Bang Theory isn't just a compelling story, it's backed by a wealth of scientific evidence. One of the most compelling pieces of evidence is the cosmic microwave background, CMB radiation, discovered in 1964. This faint afterglow is like a baby picture of the universe, revealing its state just 380,000 years after the Big Bang. The CMB's temperature is incredibly uniform, hovering around -270.4 degrees Celsius, just a few degrees above absolute zero. This uniformity provides strong evidence for a universe that was once incredibly hot and dense, just as the Big Bang Theory predicts. But the CMB isn't perfectly uniform. It contains tiny temperature fluctuations, subtle variations that provided the seeds for the first stars and galaxies to form. These fluctuations, like brushstrokes on a cosmic canvas, painted the large-scale structure of the universe we see today. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. Galaxies are moving away from us, and the farther away a galaxy is, the faster it's receding. This observation, known as Hubble's law, provided the first concrete evidence that the universe is expanding. Imagine dots on a balloon again. As you inflate the balloon, all the dots move farther apart. Similarly, the expansion of the universe isn't because galaxies are moving through space, it's because space itself is stretching, carrying galaxies along for the ride. This expansion is a direct consequence of the Big Bang. It's like the universe's initial momentum carrying it outward, a cosmic echo of that primordial explosion. By measuring the rate of expansion, scientists have been able to estimate the age of the universe, putting it at around 13.8 billion years old. Section 6. The Cosmic Recipe, Elements Forged in the Big Bang's Fire. The Big Bang wasn't just about creating space and time, it also forged the first elements, the building blocks of stars, planets, and even ourselves. In the intense heat and pressure of the early universe, a process called Big Bang nucleosynthesis occurred. During this process, protons and neutrons combined to form the lightest elements, hydrogen, helium, and trace amounts of lithium. The abundance of these elements in the universe today, as measured by astronomers, closely matches the predictions made by Big Bang nucleosynthesis, providing further support for the theory. These primordial elements, created in the crucible of the Big Bang, would later become the fuel for the first stars, igniting the universe with light and setting the stage for the formation of heavier elements in the hearts of dying stars. Section 7. Mysteries Yet to Unfold, Dark Matter, Dark Energy, and the Unknown. While the Big Bang Theory has been remarkably successful in explaining the origin and evolution of the universe, some mysteries remain. One of the biggest puzzles is the nature of dark matter and dark energy. Dark matter, invisible to telescopes, makes up about 85% of the matter in the universe. We know it's there because of its gravitational effects on visible matter, but its nature remains elusive. Dark energy, on the other hand, is even more mysterious. It's a hypothetical form of energy that's causing the expansion of the universe to accelerate. These enigmatic entities highlight the fact that we still have much to learn about the universe. The Big Bang Theory provides a framework for understanding the cosmos, but it's a framework that's constantly being refined and expanded as we make new discoveries. Section 8. Our Place in the Cosmos, the Big Bang's Relevance to Us. The Big Bang Theory might seem like a story about distant galaxies and cosmic events that happened billions of years ago, but it's also a story about us. Every atom in our bodies, every grain of sand on the beach, every drop of water in the ocean, was once part of that primordial singularity. We are, quite literally, stardust. The atoms that make up our bodies were forged in the hearts of stars that lived and died long ago, their remnants scattered across the cosmos, eventually coalescing to form our planet and everything on it. Understanding our connection to the universe and its origins can give us a sense of perspective and wonder. It reminds us that we are part of something much larger than ourselves, a cosmic story that began billions of years ago and continues to unfold today. Section 9. Keep looking up, an invitation to curiosity. The Big Bang Theory is a testament to the power of human curiosity and our insatiable desire to understand the universe we inhabit. It's a story that's still being written, with new chapters being added all the time as we make new discoveries and refine our understanding of the cosmos. So, the next time you find yourself gazing up at a star-filled sky, remember the Big Bang. Remember that those twinkling points of light are distant suns, perhaps orbited by planets of their own. Remember that we are all connected, not just to each other, but to the vast and ancient universe itself. Keep looking up, keep asking questions, and never lose your sense of wonder. The universe is full of secrets waiting to be uncovered, and who knows what incredible discoveries await us in the future.